Well, let's start. I want to redesign this car part. It's from an Audi 81 and I'll try to redesign it in Fusion 360 without any image or something. I just want to measure it and, well, redesign it and kind of guess the geometry of the part. My caliper is not big enough for the part, so I will use not so specific tool. Won't be measuring it so precise. But I kind of can guess the length. It's 20 centimeters. 20.1. I will have to write it down, kind of sketch the geometry on my white paper. Okay. So this is my sketch I will work with. And for the length I have 201 millimeters. On this side we have until the corner of the radius, we have 85. This piece is 12.5. And it will be hard to exactly match the position of the Audi logo. We'll need to check if this will be a problem. It's 53 by 35. And I think I will get the position by measuring out the distance from this corner and this corner here. It's 11. And 33.5. I think very difficult will be to get the exact angle. I think first of all I will make the plane and then look forward how to add this angular surface here. This is what my sketch now looks like. Kind of messy, but I know what to do now. Maybe I have to measure the short side here. If the caliper is long enough, which it is. I'm measuring to the middle of the radius. This should be good for the designing. Not very precise. I would guess it's 15.5. Kind of rough measurement. But as you can see, the part is really bent. So I think you have, on the old cars, you have higher tolerances than on new cars. So with some guessing, this should be fine. I'll note 155 millimeters. Okay. Again, to show you my messy sketch, an estimation of the part, and let's jump into actually designing it. So we'll start with a sketch, of course, and start on the Z plane. And I think, what side did we have? This should be the right side. Why is this important? Because I could use this surface here to mirror it in the end. So I will design it from your vision. It should be like this, and I will see it like this. I'm guessing at least. Should be right. Let's see. Okay. We'll start with a line and we'll make the first line 58. Oh, that's nice. And then we'll go 155. And then we'll go from here to maybe hello. We'll go 201. Then we'll connect this, and we have the rough surface geometry of the part. Then we'll make the hole. We need an which will be 53. Never did this before. 3. How does this work? Ah, okay, nice. We go 35 and we have our hole. And now we use the corners. Get the dimension. So we measured 33.5 millimeters distance. Ooh. Well, this did not work at all. Do it in another way. We'll have to add the half distance of the ellipse to the distance of the corner I measured. So it's 26.5 adds to, it's hard to calculate in English, 59, it's 60. This works better. 60, and here we have 17.5 and 11, 28.5. Nope. Come on. Okay. So this is the first sketch we'll do. Now we're gonna extrude it. And I did not check the thickness of the part. It's 4 millimeters. 4 point, even number 4. Okay, this is where we start. We'll add the details like draft angles or something later. First of all, we'll try to make the, I hope you can see it, the angular surface here. And I will need to think about how to measure this. I have nothing here to measure an angle. Then we'll make measurements like this. The height is the height is 12.5. And distance is, I think it was 12.5 in both directions. Ooh. No. 10. we'll need to make a sketch on this surface, and this is the top side, so we'll go like this. We go down. Let's do the following. A line here and make the distance. What did I measure? 10? 10, I think. 10. And the height 12.5. This should be the geometry we're looking for. Okay, let's make another line. Make it parallel. It's already parallel. And then cut it. And let's trim it. Trim. Okay. Good for now. Hi, Syntoxic. Okay, basic geometry is ready. Let's see for some details. First of all, we have some drafts on this plane and kind of messy. And we have some cutouts. Okay, let's make a draft. I don't really know what draft angle this is. But I think guessing it should be totally enough. I don't know if you can see this actually. Oops. Okay, we'll use the draft and whoops, wrong. I'm never getting it right on the first time. I would say 15 degrees is what it looks like. Yep. Okay, then we have this, well, what's it? Could be aluminium, could be metal insert in the part. We'll need to make a offset geometry in this angular surface. My friend who needs this part for his car, he'll replace this one, and I don't really know what he's gonna use, so I will put their generic surface, which I have to check with him. But first of all, if the part is ready, we will need to check if it does actually fit to his car. So we will look it good and make it printable first of all, which shouldn't be a big deal. And then we will take care later on details if we see that the part actually fits. So we will make a sketch on this surface and measure distances. Again, we have from the... It actually goes all the way through the part, but we'll make it like it can be glued into place. So we'll make 2.5 millimeter from the right side. We'll start with a basic shape here. Make it 2.5. And then we will measure the thickness. It will be 11-ish. Oops. Why does this not work? If you're not seeing what I'm measuring, just tell me. As I said, this is my first stream my first stream on YouTube. And if I have to improve something, just tell me, let me know in the chat. I hope you actually can hear me, I don't know. So I'm measuring the distance from this corner and it's 4.2. I think it would be enough if I round this to 4, but now I have measured it, so I can actually go for it. But why is it over constraining? I should give it one more. Yeah, should work. Well, in real, it also goes very close to the edge. I will need to see how it works with the radius I will put later on the top. It's a, if you missed it on the beginning, it's a car part. I don't know the English word, Zierleiste. It's from an Audi Type 81. So I think layer orientation will not really matter, but the part actually is kind of wavy, but as my friend said, this should be a plane surface. So I can place it like this on the build surface, which will benefit two things. First of all, the print quality of the surface you can actually see will be very good, and you don't need any supports. I have the issue that if I use supports, the first layer over the support will not be as good as maybe if you place it directly on the plate. So your question, I would say the stress is minimal. He will glue it in place and it will stay there. It's not a functional part, and so the layer orientation I think won't really matter. Yeah. I think what I'm more concerned about is if I or he will be painting this one, if it actually will withstand cold and heat and rain and salt and everything. So German weather. It's hard, but it's an old car. I think it's his yeah, not a summer car, but his car for a Sunday ride. So I guess there will not really be much stress for this part, except direct exposure to sunlight. Yeah, we'll see. If it fails, we'll make a new one, or he will buy genuine parts, but they are pretty expensive, and that's the issue here. Okay, let's go on. But thanks for the question. We have, I have to turn it. It's now, did I make it right? Oh, the draft angle is also on this surface. It looks kind of weird. Okay, but the part also looks weird. Okay. Yes, and this will be in on next video. I actually thought about buying XTC 3D, but I went to a local hardware store, you might know, Obi, and I bought some random epoxy, and I basically thought, yeah, XTC 3D is nothing more than a standard epoxy. It might have different mixture of A, B component and might cure faster or slower. Something they have to make different to standard epoxies. And I already tested this one and it gave me some very good results, and it's pretty cheap regarding to XTC 3D, which by no means is bad product. With what regarding what I have seen, I didn't use it myself because I thought it's a really tiny bottle and it's pretty expensive, and you have epoxies all around the place. I used some epoxy for DFK, so glass faser, and I basically also ordered this one on Amazon. It's a putty. Isn't it optimized to bond to prints? I don't know if this is really the key fact. Could be, I don't know. You can see in the background there is my Iron Man helmet, and I can show you what I did here. I basically had some failures on the print, and these were the side plates of the helmet, which fell off the build plate because they had very little contact surface to the build plate. And I used it for some tests with sanding, and then this random epoxy, and then I did 2 layers of primer and 2 layers of red car paint. I didn't put on a clear paint because I just wanted to see how it works, and this part especially is quite interesting. I hope you can see it. It's a bit small, I know. One side, it's this side here. I only sanded. it and then did 2 coats of primer and then 2 coats of paint, and I hope you can see the layer lines. It's pretty hard. And I covered this one with blue tape and then applied epoxy on the right side. And this one I only applied the epoxy, and the lower surface I applied the epoxy and then sanded the epoxy. And where basically you have on one print, on one try, you have 3 different surfaces. You can see on this side it's clearly visible that here the layer lines are still visible even with the primer and the 2 coats of red paint. And on the top surface you also can guess the layer lines, and what I have seen from this epoxy is that it forms little bubbles on the part, which are not big, but if you can look, if you can see it, I don't know if you can see it, sorry, it's pretty bad setup right now, but I think you can guess it. And on the bottom I tried to sand it down very carefully, and the primer, the epoxy does sand down very easy. It's very easy. I used sanding sponges, 3 different types, and then I primed it. I sanded again and primed it, and then painted it, and it looks very good. What you can see is the whole part is kind of skewy or wavy, but the surface you can receive is very good. Sanding, epoxy, sanding, filler, primer, sanding, primer, paint. Okay, it's basically the same as I have done here, but I did not use a filler primer. I used a standard primer. What filler primer are you using? I'm using some the cheapest of the cheapest. Duplicolor cars, I think. I don't have it here. Duplicolor cars. It's like €4 on Amazon. So I wanted to go very cheap, receive the best results you can get. This was my goal. I think it's back. Thank you. What did I want to ask you? How is your experience? Does it fill the gaps? Thank you. I have this cord set up like 20 meters, and can unconnect in 2 points actually. 1 point was unconnected. I have a little delay between the chat and I think what I'm saying, but would be curious if your experience is what your experience is with the filler primer. if it does really fill in the gaps. But if you have filler primer, do you really need the epoxy or counterwise? Would be curious to know. Yeah, okay. Okay, I think I have to try this out. I have, when I'm finished with the Ironman, I hope it will be soon. I didn't put a video up 2 weeks because it's really time consuming and I'm lazy to send away. Yeah, that's a hard job. That's a freaking hard job. Sanding PLA is not very nice. So I did sand all of the helmet, but yeah, I didn't do my best job there. It was really rough sanding, and I'm really relying or trying to rely on the epoxy, but I really think, as this is my first bigger cosplay painting project, except for the Han Solo blaster, it will not be as good as I hope it will be. I have this one surface here, which took a lot of time. I don't think I can spend the amount of time I've spent on this little surface on the whole helmet. So it might be a good tip. Okay. Yeah, as I want to say, after the Iron Man helmet, I want to make another helmet. It's from Player-Unknown's Battleground, the level 3 helmet. I'm currently designing in Fusion 360, and this should be, or I want it to be, my next project after the helmet. We'll see. Okay, I'm trimming surfaces here, and I think we should be ready for now. So we now made a groove for this, yeah, metal or aluminium insert. I will need to see if I have a magnet. I need to stand up. Hopefully I do not unconnect the sound again. You can see my nice sweatpants. So it's not magnetic, so I would guess this is aluminium. Quickly going for a Twitter post. I forgot to tell the people that I'm live. When will he ship? Did you already order it and received any information? I don't really know when it was. Was it in October or November? I'm trying something with the stream, and no, I can't change. I want to go for ultra low latency, but I cannot do this. Dashboard. February! Wow. Damn, man. I ordered my Mark IIs in, I think it was May, and received it in July. And now that he is up to, so he did acquire some stock of the Mark IIs. He put out the Mark III, so I think it's good for him. I think it's a very good printer, but it would be very nice if he can kind of deliver it in 2 or 3 weeks. The waiting was a very big pain. But I love the printer. It prints awesome, but I hate waiting. Okay, we have the geometry here, and we will extrude this. I would say it's 4 millimeters thick, and we'll go with 2. Oh, wrong side. Wrong side. -2 point. Okay. So I would say we will give this beauty some radii, and we will check what will look good. Yeah, it's well, I think the benefit is there, but the leap is not very big. You have some nice features I really would like to have also, and this is the power panic, the filament sensor, and I think the bed also. I think the Mark 52, I think it's called, will be better because you cannot damage it so easy. And I'm really careful with the Mark IIs bed, and it's also good, but if it would be, the PEI bed would be damaged, I would even consider an upgrade to the Mark 2.5. I don't think that the extruder upgrade is really necessary, and the Pinder 2 probe with the ambient temperature, I think he said, Joe said himself, that the print quality is not really better. It's almost the same, I think. Correct me if I'm wrong. So it has some nice features. I think new people who consider buying a printer and they want a reliable, high quality printer, they are very good. They have a very good deal with the Mark III. You are buying one too. So what is your argument to buy the Mark III? And yeah, he's a bigger factory and he can't keep up. He will keep up after the first wave of orders. I think it's a very high peak now because of the hype. It's a good marketing, you have to tell. You have to think as a businessman, so he did a good marketing. he announced it at the right moment, and if he keeps up with his speed of iterations of printers, it will be a good business for him. And you also have to think of this, his business has to be helpful, healthy, not helpful, so healthy, and I think he's doing quite well. And the printers, yeah, they speak for themselves. They are simply good. Yeah, the bad is good. The microstepping, the question is why? Does it give you any benefit in print quality? I'm really not so deep in the matters of microstepping. And yeah, the probe, well, if you have it in a chamber working, yeah, you kind of can compensate higher, lower temperatures. It's well, I think it's kind of luxury. I don't say I wouldn't take a Mark III. If I would consider buying a printer, I would also buy the Mark III. Well, I bought the Mark IIs, so the choice is always kind of the same. But I think the benefits are luxury benefits. And I will not upgrade my printer. Ah, okay. That's a huge point. I really forgot about this. I have my Hypercube printer, and it's so much quieter than my Prusa. But I think this is not because of the microstepping. This is just a general. I don't know if it's really about the rigidity of the printer, but I think it's also a design issue. The microstepping might help, but I think the design of the y-axis also might help with the silence of the printer. So the new y-axis, I think, also has something to do with maybe vibrations or the with the noise of the printer. Oh, okay. Yeah, he did show this. When the printer loses steps, he kind of, I don't know how did he do it? Did he compensate it? Does the print stop? Okay, and then if the print stops, does he kind of, well, does he home to a position and then restart, and then they can restart if you think it's okay? Or is the print just over? Ah, okay. That's very nice. Yeah, I don't want to argue about any benefits of the Mark III. It has benefits, of course. I did forget about all those benefits you just mentioned. But as said, I think well, upgrading to 2.5, and you have the new option that you can even upgrade to a Mark III, but it costs like $400. It's not really an option. You could buy another Mark IIs kind of, but he also wrote this in his email. But what does he do then? I thought he can compensate for the ambient temperature, which does affect, correct me if I'm wrong, resistance inside the printer probe. So if you have like 60 degrees Celsius inside the chamber, the height measurement of the auto calibration will be another if you have it working at 20 degrees. I thought this was the issue. I will need to look it up. Mark III. Yeah, it's an ambient thermistor, so I think it does measure ambient temperature and temperature in the printer probe. Yeah, one is measuring ambient temperature on the electronics. This helps us prevent non-intended min-temp areas when start a print in easy areas, in areas with 15 degrees or less. It also detects a board or connector failure. Second one is in the printer 2 probe tip. The induction sensors have a temperature drift, meaning that different temperatures might cause the probe to trigger at a different height. Now we can compensate for it. Okay, yeah, I kind of mix it up. Well, but if I look at the first layers which I'm producing on the Mark IIs, I cannot really remember a bad layer. And what I can see is if I'm printing flex material, I might have some issues that I need to go a little bit higher. But the temperature on the bed is not really different. I have 5 degrees difference. So I would guess the 5 degrees is not really the big point. And if it is not sticking to the
to the build plate, I did see that if my printer is standing around for I think a week and I'm not printing, it's kind of dusty and then it does not stick, so I have to wipe it off again. So yeah, it's a benefit, but do you need it? One millimeter, okay. Okay. Well, 1 millimeter is very big. This leads to a lot of issues. But I printed once, I printed some ABS parts for the Hypercube build on the Prusa. And I don't really know if I did adjust the first layer height. I don't really know. And if I did so, it was not really big. It was maybe 0.1, 0.2, not more. And I'm printing with, I will need to look it up, my ABS settings. Where? I think I use Prusa ABS. And yeah, 100 degrees. What? To conclude everything, if you have the Mark III, you just have to tell me how it works. I think it will be is a very good printer. I'm kind of curious. I also want to have a Mark III. The benefits are there. Yeah, but I'm printing ABS, I'm printing PLA, I'm printing feeler flex material, I'm printing patchy. Well, what I did not really print is some extraordinary carbon fiber filament or what is there? I'm receiving some HDPLA, but I think this will print according to the PLA. What you of course have to do if you're printing without the probe, you have to adjust. You have to adjust from time to time. Heights, first layer heights, you have to live tune. But it's very easy. You jump into the print, and if you see that the first lines are too close or too far away, especially if they're too close, you can easily adjust and live tune the height, and it saves the height. If it's too far away, well, you have to abort the print and do it again. Yeah, it's a benefit, of course. Yeah, I did in July, I did my first ever live stream, and I did a live build on Twitch. And I don't know where it is. The live stream is gone on Twitch, but it took me over 9 hours to assemble the whole printer. And then I ended the stream, and it took me I don't know, I had to eat and everything, and it took me 1 more hour or 45 minutes because I think I had a temp error. I did connect something wrong on the board, but the manual actually said it to check the connection, and yeah, it was 9 hours. I think if you're used to assembling printer, you can do it a lot faster. Because of the live stream and talking to 2-3 people, it took me a little bit longer, but yeah, it's a marathon. Uah. This looks bad. Everything is rounded on this part. Everything. I have this thought in my mind, and I think it's the same thought you have. I did not want to make a hypercube evolution. I was thinking about going much bigger. I wanted to make not a real own design of a hypercube. I wanted to redesign it to make it super huge and put a E3D volcano on it with a huge nozzle. This was what I was thinking about, because I'm mostly using the Prusa. It's good and it's reliable. The hypercube does now print very good, but the build surface is limited, and I want a printer which can produce very big parts. And as I don't want to afford another printer at the moment and in the near future, I was thinking about, designing own parts, like second Z-axis, go huge, and kind of combining 4 heat beds, which I don't really know if this is possible. So I didn't have any deeper thoughts about this. I think it would be easier to buy a, I don't know, maybe a CR10 with a big volume. 40 by 40 by 40. Is it the build volume? Yeah, I guess so. I'm still I'm thinking about what bed can I use? Which is the biggest bed you can get? I did not make any research. We can do a little brainstorming. Okay. What? Okay, the first site I saw on Amazon was $200. No. Okay. 16 by 16 inch. Is it 60? Woo! Holy moly. I post a little link. I hope it's not this one because it's super expensive. Yeah, I'm shocked about the first two sites I opened, which, yeah, it's the CR10 S4, I think with the 40 centimeters, it's like $500, $600. Well, it's a CR10, okay, but it's like 60%, 80% of the price only for the heat bed. This is insane. Yeah. This might be true. The Chinese can produce everything for cheap. Okay, I think we will need to make it a little bit thinner from the back side. I don't know if you can, yeah, I think you can see it. It has some, yeah, kind of small ribs where it is glued in place. I will try to redesign them. I think you could also leave it like this with a plain surface. I don't know how it looks on the car. Yeah, sure. Would be a fun project, dude. It's like, but I wanted to make it really big, yeah. So like four 20 by 20 build plates or heat beds, but I'm really not so deep in electronics. I want to think about how to connect them together because you need to control every heat bed, and you need a lot of thermoses. I don't know which board can handle that much thermoses. Or you place your thermistor in the middle of the connection point of 4, but then you have a, yeah, not so exact measurement of temperature, I guess. But I think this will be no issue. If you have like a 1.2 millimeter nozzle, so much plastic comes out of the nozzle, it will stick to the surface. And if it does not work, you have maybe with a unheated build plate you can print some huge PLA parts. It should be like a part daddy. Okay. Thanks for watching. Have a good night. So let's try to redesign the geometry. I think I will do a little construction line if I can find the point here. 20 millimeters and a construction, and we go parallel to up to 17. Ooh, looks like. Make it. Okay. Okay, we're continuing with the inner geometry. And this will be very rough because this piece is glued in place. I think this doesn't really matter. It's just for the looks. $50, $45 should be enough. Thickness is 7. Then we'll go back. All the way to the end, and four millimeters only. Distance 37. Go for 11 again and work the way up. Come on. Trim it off. Should now have geometry. Let's do some extrusion. Go for -1. This should do the deal. Yeah. Kind of looks like
this part. We are pretty close. So the logo can actually fit inside. And we have the radii. This will be our printing surface. This should... I wonder if this can actually print very good. But I think we will see. Well, I will first of all save my progress. This should be right. And we need a left one also, so I will mirror. Where are the planes? Where was... oh, okay, mirroring. Why? Ah. Let's make an offset plane. Offset plane to this one in 10 millimeters and mirror on this plane. Bodies. Okay. We should now have a left and a right. What we can do is put a left and right in there, but I think it's not really necessary. I think I did construct it upright, upside down, which is kind of bad, but you can place it in the Prusa slicer. It should be like this, but the Z of course should go up. Okay. Yeah. I need to see if I can export them one by one. Yeah, should be good. So the next step will be that I will export the file as an STL, and we can name them. Can you actually rename things? Nope, don't know how. Well, the next step will be to export them as an STL, see if it prints well, do a little bit of sanding. I think maybe I need some putty, I need some epoxy. I will try the spray putty, which Syntoxic recommended earlier. It was look it up again, press.
Okay. I will need to order something of this. And I think for today we are done. I think we went from this to what you can see on the screen, and I think it does match the geometry pretty close. The intention was not to recreate it 100% perfectly, because I think you have some tolerances. If you look at the part, it is bent quite well, and I will call it good for today. Thanks for watching, and yeah, do not have a good day, have a good night.